Hello students, from today I'm going to launch this physics CBSE for 11th class syllabus by the way of videos. You must know that I will try my best to cover each and every chapter with 3 or 4 videos, small videos. So by the way of these videos, you will be able to learn theory portion of physics 11th class syllabus related to CBSE. So my intention to bring this series is that there are many students who don't know Hindi, or the students residing in foreign countries. They may also learn from these videos. They will get benefited from these videos. So for them, I'm going to launch my English series, and kindly also subscribe our channel so that you may be connected to our videos, and also press the bell icon so that any further videos when they are launched on our YouTube channel, you may get notification for that. Okay, so let's start. So this is our second chapter, units and measurements. So first chapter, as you all know, is related to this physical world, which is just a introduction, or we can say general knowledge type chapter. So here we are going to start our syllabus to the second chapter, that is units and measurement. So let us see, our first article is fundamental quantities and derived quantities. So students, we must be aware about the fundamental and derived quantities in physics. So what are fundamental quantities? So here we must know that in physics, there are many quantities which are independent in nature and have their independent units. So such quantities are known as fundamental quantities. So these are length, mass, time, etc. Similarly, when we talk about the derived quantities, so derived quantities are those quantities which are made up of two or more fundamental quantities. So in this section, we can understand that if we talk about the force, force is represented by mass into acceleration. So as we all are aware about the formula for force, force is equal to, that is, mass into acceleration. So mass is a fundamental quantity, and acceleration again is a derived quantity, right? So force is made up of more than two physical quantities. Similarly, we can say velocity. So what is velocity? This is displacement upon time. It is also made up of two physical quantities, and which are originally fundamental quantities, right? So derived quantities does not have their independent units. They are made up of fundamental quantities, and their units are also derived from those quantities, right? So this is about the fundamental and derived quantities in physics. Now let us go to the second article. This is scalar and vector quantities. So students, what are scalar quantities? In physics, we must know that there are many physical quantities, many of the quantities which have only magnitude, and some of the quantities, or many of the quantities are there which have magnitude as well as direction, right? So those quantities which have only magnitude and does not have any direction are called scalar quantities. So in this case, we can take the example of mass and time, because mass and time does not have any direction. While the vector quantities, as far as vector quantities is concerned, these are the physical quantities which have magnitude as well as direction, right? So velocity is the best example, or displacement is the example of vector quantities, because they have the direction. So by changing the direction, their value changes. Means when a body is moving in and its direction is changing, then it means its velocity is changing, right? Now let's go to the third article. This is systems of measurement. So as far as systems of measurement are concerned, so there are different systems of measurements. So we must know that the very first system which was introduced by our scientists in the past history is FPS system. So FPS system is foot pound and second system. In this system, there were originally three fundamental quantities. They were length, mass, and time. And their respective units were foot, pound, and second. This system was known as British system and is the oldest system in our science for the measurement of physical quantities, right? But later on, after some time, um, two new systems were introduced. They were known as metric systems. So why they were introduced here, or why we can say metric systems were introduced? Because in foot pound second system or in FPS system, there was there was complication in calculations because as we know that 1 foot is equal to 12 inches and similarly 1 yard is equal to 3 feet and so on. So when multiplication, division or addition or subtraction operations were conducted, so it was quite typical for large quantities. So that's why to reduce this complication, matrix systems were introduced. So the matrix systems were of two types. These were MKS system and CGS system. In these two systems, every conversion or every bigger unit was a multiple of 10. Okay, so when we multiply, as we can see that 1 kilometer is equal to how many meters? 1000 meters. Similarly, 1 meter is equal to 100 centimeter, and 1 centimeter is equal to 10 millimeters. So here we see that all the conversions are multiples of 10. So these two systems were quite flexible as compared to the multiplication, division, or addition or subtraction like that. But in these two systems also, the basic quantities of the fundamental quantities were only three. Those were length, mass, and time in both healthcare system as well as in previous system, right? In CGS system, the units were centimeter, gram, and second. In MK system, the units were meter, kilogram, and second, right? Now let's go to the fourth article. This is International System of Units. So after that, after our metric systems, later on it was felt that a new systems shall be introduced because there were a few more physical fundamental quantities to be observed. So in this system, finally, in today's scientific world, we follow this international system of units. It basically consists of seven fundamental quantities and two additional quantities, right? So seven fundamental quantities included in our international system of units are length, mass, time, electric current, temperature, luminous intensity, amount of the substance. Their respective units are meter, kilogram, second, ampere, Kelvin, candela, and mole. So as we can see that the unit of electric current is ampere, and the unit of temperature is Kelvin, and the unit of luminous intensity is candela, right? And amount of substance is mole. So in addition to MKS system, four physical quantities or fundamental quantities were also added in this. Hence, the total number of quantities, physical quantities became here seven. These were the now these are called fundamental quantities, right? Let's go further. So now there are two additional quantities. This is the plane angle and solid angle. So the unit of plane angle is radian and the unit of solid angle is steradian. So let me convey something because it is not related. Steradian is not in your syllabus in 11th class. But let's see just an introduction. So as you know, the plane angle, what is plane angle? As we know that when we substances draw an angle in our coordinate system, suppose it is x and y axis in a plane. So as we know, a circle subtends an angle of 2 pi radian at its center. So the entire angle is also known as 360 degree. So hence we can say 2 pi radians is always equal to 360 degrees, right? Now, when we talk about the solid angle, so solid angle is something angle subtended by a volume. Suppose we consider it a sphere. So the surface area of the sphere subtends an angle at the center of the sphere. So that angle is known as solid angle, right? So the unit of that angle is steradian, correct? So let's go. Now we are going to next topic. This is our plane angle. So let's see plane angle. What is plane angle? Now, a solid angle is not in your syllabus, so we will not study it later. Now, let's see, this is plane angle. So what is plane angle? The angle subtended by an arc on a plane is known as plane angle. The complete angle subtended by a circle at its center is as under. So plane angle is equal to the circumference of the circle upon radius. So this is 2 pi r upon, we can write r. So r will be cancelled. The total angle is 2 pi radian. And as we also discussed that the circle subtends an angle of 360 degree at its center. So that's why um, we can write it here as far as conversion is concerned. So here we can say a relation between degree and radian. So 2 pi radian is equal to 360 degree, or 1 radian is equal to 180 upon 5 degrees, right? Similarly, we can say 1 degree is equal to pi by 180 radian. So this is mandatory values, or we can use these values for converting either radians into degrees or degrees into radians, right? Now, from the first formula, as we see here, plane angle is equal to circumference of radius. By this, we also introduces here one more formula, that is theta is equal to arc upon radius. So you can see that, right? So this formula is also very important, and we will use it in our numerical problems. So later on. Now, this conversion is clear. Now, here, students, one thing I want to clear that, as we know, in case of time, 1 hour is equal to 60 minutes and 1 minute is equal to 60 seconds. So, as we know, there are minutes and seconds in time. Similarly, there are minutes and seconds also in case of degrees. So 1 degree is equal to 60 minutes, and minute is denoted by single s. Okay. So one, you must remember that 1 degree is equal to 60 minutes, and 1 minute is equal to 60 seconds. Right. Second is denoted by double dash. Let's go further. Now, this is our sixth article, units used for measuring large distances. So, apart from this, our fundamental quantities, 7 fundamental quantities, there are some more units also for measuring unapproachable distances or very long distances. As far as the distances of stars and planets are concerned, we uses three units. These are astronomical units, then light year, then parsec. So let's see one by one. So what is astronomical unit? So one thing you make in your mind, if we have to find out the distance from the center of the earth to the center of the sun, then that distance basically is known as astronomical unit. So to define it, how we'll define it? The distance from the center of the earth to the center of the sun is known as astronomical unit, or it is represented by 1 AU. So 1 AU is equal to 1.496 into 10 to the power 11 meters. Okay, it is a very long distance. Now, one thing comes in our mind: can this how this distance is calculated, and how we can calculate this distance? So let us see calculation. So since we know that distance is equal to speed into time, so this formula is well aware to you, or you have learned speed is equal to distance upon time in your previous classes. So here, now we know that the light coming from the sun up to the earth takes approximately 8 minutes 20 seconds. approximately 500 seconds. So here what we will do, how we will calculate it. The speed of light is 3 into 10 to the power 8 meter per second, and the time is 500 seconds. So by multiplying, we can see that the value comes to be 1500 into 10 to the power 8, or 1.5 into 10 to the power 11 meters. So it is almost equal to 1.496 into 10 to the power 11 meters, right? So the time taken by light, so that I have already told you, the light takes 8 minutes 20 seconds for coming from sun to earth, right? Now, next unit is light year. So what is light year? Here we can see that the distance covered by the light in 1 year is known as light year. So it is light year is basically the unit of distance. So 1 light year is equal to 9.46 into 10 to the power 15 meters. So this value can also be calculated easily from the same formula. Distance is equal to speed into time. So as you know that in 1 year, there are 365 days, and in each day, 24 hours, and 1 hour has 60 minutes, and 1 minute has 60 seconds. So time we have to convert into seconds. So let us see, the speed of light is 3 into 10 to the power 8. Now into 1 year is time. So 1 year is converted into second, that is 365 into 24 into 60 into 60. So hence by calculating this value, we get 9.46 into 10 to the power 15 meters. So you must remember this value. 1 light year is equal to 9.46 into 10 to the power 15 meter, and 1 AU is equal to 1.496 into 10 to the power 11 meter. So I think both the units are clear to you. Now here comes Parsec. So what is Parsec? So students, what is Parsec? Here from the figure, let us first of all understand this Parsec. Suppose there is a point O, and there is an arc AB of length 1 AU. There is an arc whose length is 1 astronomical unit. So at that point, at point O, this arc subtends an angle of 1 second. Okay. So here we can say, when we talks about this, when an arc subtends an angle of 1 second at any point, then the distance of that point from the arc is known as 1 parsec, right? So here is the definition. Whenever an arc of 1 AU length subtends an angle of 1 second at a point, then the distance of that point from the arc is known as 1 parsec. And you must remember 1 parsec is equal to 3.1 into 10 to the power 16 meter. It is the biggest unit out of the three. So in all these three units, the value of 1 parsec is highest, right? So this value can also be calculated. So as we know, the formula theta is equal to r to the radius. So what we will take here? Now here theta is 1 second. So 1 second is to be converted into radians. How we will convert? So first we will convert 1 second into a minute by dividing 60, then into degrees by dividing the 60 again, and into pi by 180 to convert degree into radian. So this is the value of 1 second in radian. Now arc AB, the length of arc AB, as we know that this is 1.496 into 10 to the power 11 meters, right? So this we have taken. So now in this formula, theta is already known to you, radius, sorry, arc is known to you, then we have to find out the radius of the arc. So let us calculate. Now R will be equal to AB upon theta. So by putting the values, this is 1.496 into 10 to the power 11 into 180 into 60 into 68 upon pi. So on calculation, it gives 3.09 into 10 to the power 16 meters. So the entire radius of the arc becomes, this is 3.1 into 10 to the power 16 meters. So this is the value of 1 pass. So I think this is also clear to you, right? Now here comes the next article. This is seventh article. Methods used for measuring unapproachable distances. So students, we must know that in our daily life there are many more distances that we can measure directly with by the use of tape or scales or any other instruments. But there are some distances which are unapproachable and which cannot be measured by the tape or scales. So to measure such distances, we use different methods. So these methods are echo method, radar method, laser method, sonar method. So you must know that this first four methods, they are also known as reflection methods because they work on the phenomenon of reflection, as we have studied reflection of light. So here they work on the phenomenon of reflection of light waves, or we can say reflection of sound waves, like that. And the fifth method is triangulation method. Triangulation method is nothing but the method of finding the distances or heights by using trigonometric identities. So as we know in heights and distances, in previous classes, we have calculated heights or distances of certain buildings, trains, or width of the river, like that. So such methods are known as triangulation methods. They involve totally the mathematics or mathematical identities related to trigonometry. Now, the sixth method is parallax method. So parallax is something when we measure some angle with respect to an object which is situated at infinity, and we measure the angle of a finite body, a body which is located at a finite distance with respect to the object situated at infinity. So that method is known as parallax method that we will see here. So let's see. Let's go now. What about this reflection method? First of all, see reflection method. So first method is echo method. So in this method, what we do, there is a person, there is a hill. Also, when we emit sound, the sound goes to the hill, and after striking the hill, it reverts back or reflects back. So in this case, we can see that this, in the forward direction, sound had traveled x distance, and after reflection, it again covers x distance. So the total distance covered by the sound is 2x. And if the total time is t, then here we can see that time is equal to distance upon speed. So time t is equal to this is 2x by v. The v is the speed of the sound. So by rearranging this expression, we can see that x is equal to v into t by 2. So this formula can be used to find out the distance of hill from the person. So such a method is known as echo method. And its other example is we can see that if we are standing in a bigger hall, bigger cinema hall, theater like this, so when we speak something, our sound reflects back and reverberates and comes back to us. So we listen to our own sound multiple times. This is called reverberation, right? So, because hall is small, but as far as hill is concerned, hill is far, so it takes much more time. When we stick something, it goes up to the hill and returns back after reflection. So there is a time lapse between that. Okay. So echo method is a reflection method for measuring the distance of an object. Now, this radar method, laser method, and sonar method, they are also reflection methods. In radar methods, we find out the locations of the spy planes or aeroplanes like this. In laser method, we find the distances of the stars or planets and all that by sending laser lights or the radiations which we sense travels with the speed of light. Similarly, in radar method, we use radio waves. So they all also moves almost with the speed of light, but not we can say that they always move with the speed of light. It is not necessary for these radio waves. Correct? Now here comes the sonar method. Sonar method is a method, reflection method, which is used to find out the location of something or ships or submarines inside the water bodies or ocean. So sonar method basically is used in this water bodies in oceans to find out the locations of submarines and all that. So these are all reflection methods. Here, we must know the full form of these radar, laser, and sonar. So radar stands for radio detection and ranging. Laser stands for light amplification by stimulated emission of radiation, and sonar is sound navigation and ranging. So these full forms are very important. You must know them. Okay, now here comes next method. This is parallax method. So parallax method, as I have told you already. So first of all, I will try to clear the diagram, and after that you will be aware about this. So let us see. This is our Earth. Suppose A and B are the diameters, and of the diameters from the surface of the Earth. Now here O is an object whose distance we have to calculate from A or B, right? So what we do, how can we measure it? We consider infinite objects or far objects. Suppose there is a star. So with respect to this far object, we measure the angle of O from point A. So let this angle be theta 1. So if this angle is theta 1, this angle will also be theta 1, right? Now, now we, in the second time we goes to point B. At point B, we again measure the angle subtended by O at B with respect to the far object, same far object, because it is at infinity, so it doesn't matter where we stand. AB is very small as compared to the infinite object. Okay, so this time the angle is theta 2. So it means this angle is also theta 2. So the total angle subtended by object O at AB diameter is theta 1 plus theta 2. So by the formula, theta is equal to arc upon radius. So theta is theta 1 plus theta 2. Now this arc AB is the diameter, OA is the radius. So here OA can be calculated by this formula. So the formula is original, theta is equal to arc upon radius. So this method of determining the value, either we can calculate the diameter or we can calculate the radius or anyone. So this method is known as parallax method. So if we now read it, this method is used to find out the unapproachable distances by measuring the angles of an object from two different locations. These angles are measured with respect to the far located object or star. Let us understand with the help of this figure. So now I think this is clear to you. Okay. So students, today let us close our class up to here, and in the next class we will move forward. That is dimensional analysis, another important part of our second chapter. So in the second video, we will clarify all the terms or all the concepts of this dimensional analysis. So in today's video, just this was our last topic, and now let's conclude our class here. And in for next videos, please be subscribe our channel and also press bell icon so that you may get the notifications for new videos. And surely, definitely, you follow these videos, you will be able to learn the theory portion of entire 11th class. And for numerical problems, you can contact us for online classes. But you must be aware that our online classes will be the paid classes. And when you contact us, we will surely definitely provide you the teachers for different subjects. Okay, so now let's close our class. Thanks a lot. Be connected to our YouTube channel. Okay.